So today's episode is about authenticating real-world assets in the digital space and vice versa. It's a bit like a bridge what we talk about here, just not the type you would typically hear from this podcast. In this episode, we shake up the snow globe on the barcode, and I'm not talking about sticking your friends with a bar tab when you have to leave early. The barcode was a great innovation for the time. It had only one dimension, but it was well suited to its use case. Then came the QR code and its variants, but as we move into a world where collecting interrelated forms of non-fungibility, as well as cataloging and authenticating them, is increasingly important, it might be time to look at this again and take the next step, whatever that is. Trusted IRL, or in real life, is one effort underway to take that next step with some pretty interesting technology underpinning it. I'm sure you're going to find this episode fascinating. Welcome to The Encrypted Economy, a weekly podcast featuring discussions exploring the business, laws, regulation, security, and technologies relating to digital assets and data. I am Eric Hess, founder of Hess Legal Counsel. I've spent decades representing regulated exchanges, broker-dealers, investment advisors, and all matter of fintech companies for all things touching electronic trading, with a focus on new and developing technologies. So today on The Encrypted Economy, we have two guests, Dr. Sharma and Chris Tu. Now, Dr. Sharma is an industry pioneer of scan technology. He had leadership roles at Bell Labs, Symbol Technologies, Lucent, and more recently, Zortag. He leads the Stony Brook Center for Wireless Technology Initiative, and he has 25 patents, 75 papers. He's done a lot. He won a National Medal of Technology, a Deming Prize, Shingo Prize for Excellence in Manufacturing. So he is one guest. And we also have Chris Tu. He is the co-founder of ZK Ladder and ZK Utility. He established Realtic, now SS&C, marketing leading EMS in the Asia Pacific. So welcome both of you to the Encrypted Economy.
Yeah, thank you, Eric. Thank you for having us.
Glad to be here, Eric.
Excellent. So we're going to start off with a little bit of background. And Dr. Sharma, you have quite the background going all the way back to Bell Labs. I think probably a lot of my listeners, Bell Labs may not even be part of their vocabulary. They may know something about it, but not a lot about it unless they read a book about it or something, historically. So, well, let's just start off with maybe a little bit about your time at Bell Labs, just because it's so unique. Why was Bell Labs so significant for innovators? Let's give a little backdrop.
Bell Labs, as at least the old timers would know, it really was a very pioneering institution, unique national asset. I think AT&T call it the crown jewel of AT&T because of the inventions. I think this was probably the only industrial enterprise which won almost 7 Nobel Prizes, starting from the early days of quantum mechanics when hardly anybody knew about it. So a very pioneering institution that basically ushered the electronic era to the world with the invention of the transistor radio and, of course, the communication technologies and even the internet that we presently know these days. Some of the early foundations of that was laid at Bell Labs. So very prestigious place for the country. And when AT&T was broken up, obviously Bell Labs went with Lucent because it was the research arm of AT&T. So communication part went separately, the manufacturing and the Bell Labs went with it. But almost everybody realizes and understand whether it is the semiconductor chipsets or whether it is the communication technologies, but for that matter, any of the present foundations of the Web 2, Web 1 in terms of the software, the C languages, and all the other languages, basically the foundation of that was laid at Bell Labs. So I was proud to be part of that institution for a long time.
Excellent. And when you look at today's landscape, What would you say is a pseudo, for somebody who's less familiar with it? How would you? Are there any institutions that have a similarity in the type of impact that they have on technology innovation today?
So a lot of the foundation of a lot of the things was laid at Bell Labs. There is really no institution like that because Bell Labs had total freedom in terms of what they needed to do. For example, even though we were in the communication area, we were doing research in biology, and we were doing research which really had no major uh, impact, or it was not felt that it might have anything to do with telecommunication. But we were free to do this. For example, when the moon landing project was started by John Kennedy, President Kennedy, the basically that program in communication area was led by one of our scientists who later on became the Bell Labs president. However, there are other institutions, I think Microsoft, Google, I think they have really taken some of the ideas and basically tried to create a mini Bell Labs. But as an institution, I think it was a very unique institution. And when it existed, it really was the foundation for a lot of the technology uh, that we presently see today.
And to just put that
Excellent.
in a bit of a context for it as well, I think Dr. Sharma is humble in this capacity, is that he was part of one of the teams that led to create the first commercial Wi-Fi device. And so just thinking about that, about innovative technology at that time and how
Yeah, so
impactful that's been.
that came during my stay at Symbol Technologies after I left Bell Labs. So in Bell Labs, some of the important things that I was involved in, for example, I worked early on the electrical contacts area. We were able to save about 15 tons of gold that was being consumed by Bell system every year. And that even in those days, that was like hundreds of millions of dollars of savings in the material science area. And even though I was a scientist working in the material science area, I led Lucent, which was part of AT&T before it was broken up. I led them to win the Deming Prize. I was the architect of that system that became the management system that is being used by a lot of people now these days. When people talk about the performance based systems, I laid the foundation of that early on at Bell Labs, and we were the first Western Hemisphere technology company who actually got that prize, and we're still the only technology company who won that prize.
Wow. So certainly exciting. Certainly did a lot. Today we're going to be talking more about barcode scanning and moving into sort of new innovations from going from barcode to QR code to trusted IRL, which we're going to be talking about. Maybe you could give us a introduction to your role with barcode scanning technology at Symbol.
Yeah, so after I left Bell Labs, I joined Symbol Technologies. Symbol again is a very pioneering company. They basically invented the laser barcode scanning. Every time you go shopping and you see all those laser scanners everywhere, whether you're in the warehouse or whether you're buying something in the retail house. So Symbol invented the laser barcode scanning. And it is fair to say that without the laser barcode scanning, we probably would not have seen some of the conveniences that we see in our present day lives. The company was founded by a professor here at Stony Brook University, actually, Dr. Jerry Schwartz, who is a good friend of mine. And he's the one who recruited me to Symbol. I really didn't want to come, but he convinced me to come and join. Uh, Originally at Symbol, I led their management processes to make sure that while we were a very technology-rich company, We were making a lot of money even on the royalties of our patents, more than 600 patents at that time. So we wanted to commercialize that. So that was my first job. Later on, I led their engineering division and their worldwide operations. So, based upon some of the, for example, everybody who looks at their driver's license, there is something at the back of that, which is called which is another kind of a barcode. We invented that also. We basically put that in the public domain. So barcode basically connects the physical world to the information systems. So, for example, if you go shopping and they scan your barcode that is on the product, it basically goes into, let us say, Walmart's information system, gets the price, and that's how you basically are charged. So it connects the physical world into the digital world or to the information system. And that is very, very critical. The only problem with the barcode is that if you're trying to use this to make sure that the product is authentic or not authentic, that's where it fails because you can easily copy the barcode. And that's the power of it, but that is also the deficiency of it. And
Right.
we're trying to do with and we'll talk more about it. What we're trying to do is how do we make sure that not only product is identified in a unique manner, but it is also confirmed as an authentic product at the same time.
Right. When I think about it, I mean, I've been around not as long as you, Dr. Sharma, but my experience is like I worked for like a library for a while when I was in high school, and we worked on the cards. I went over in the summer and we put the cards in the book, and you'd take out the book and you'd write. There'd be one card that the library would hold, and there'd be another card that and that would be the way that you returned it. And before the barcode, that sort of manual process was the way that not with cars necessarily, but a very manual process of recording and going and writing things down in a notebook and then calling, and it really didn't scale. Right. That was barcode really facilitated things like better inventory management. To your point, you were able to bring it up into the electronic system, into the information systems, and better manage things like inventories and pricing and all this stuff at scale. And so we went from the barcode, then we took another evolution to the QR code, and we're going to talk about trusted IRL in a second. But before we go to trusted IRL, I want to kind of take a pause and say, when we went from the barcode to the QR code, what was the significance of the QR versus the barcode?
So the QR code is a barcode. It's just not the kind of barcode you normally think about, which is the one-dimensional barcode. So the QR code, and there are other two-dimensional codes. For example, the code that I just mentioned, which is at the back of your driver license, is PDF 417. That is also a two-dimensional code. So QR code is nothing, it's just an evolution of the early technology, but it's a barcode. The same kind of readers that reads the one-dimensional barcode can also read the two-dimensional barcode. So, for example, a QR code stores some piece of information, and when you scan that, it connects you to the information system, like your URL or anything like that. There is another two-dimensional code which is called the data matrix code. Actually, data matrix stores more data than the QR code. So depending upon how you want to connect into the information systems, you can use one or the other.
Right. And now,
for example, UPS packages, when you see another code, which is also a barcode, but a different kind of a barcode.
Right. So in all these cases, we've moved from that being the barcode to the next dimension, and obviously the 2-dimension gives us a lot more possibilities. But I think, as I've noted in prior discussion, it does have, it allows you to record what I would call more fungible more fungible things, because that's fungible's more a limited set, sort of you're able to identify them. But then as you get into something that's more non-fungible, sometimes you have something that is fungible, but there's uniqueness within that fungibility, and you want to make it non-fungible. These are terms we use all the time in the digital asset space, but they're also a very real world issue if you're really trying to ascribe uniqueness to something that's fungible. And so moving from now potentially that 2 dimension to, I guess, trusted IRL, which is 3 dimension, that gives you more optionality still. Do you want to maybe develop on that a bit?
Yeah, and I think Chris can describe this more in terms of the connectivity issue. But as I said, when you use the QR code or any of the two-dimensional code or one-dimensional barcodes, it's easy to basically copy them. And so what we have done is we have combined the two-dimensional barcode with what we call is a fingerprint. So just like you and I can be identified by our social security number, and then our iris scan or our fingerprint, our biometrics. Now those things put together makes really us unique. So if you think about a product, in the easiest way to think about it, that it can be identified by a barcode, whether it is one dimensional, two dimensional, or any kind of a barcode. If you can give a unique fingerprint to that item becomes unique. So what we've done is that we have created an optical fingerprint which cannot be duplicated by anyone, including ourselves. So think about a liquid drop in which you drop some particles. These particles randomly move. It's called the Brownian motion. Back in the early 1905 time frame, if I'm right, and some of the work Albert Einstein actually worked in the on the Brownian motion. So these things randomly move, and there is no structure, there is no mathematical formula that you can use because everything is random and possibilities are just infinite. So now in this liquid drop, if at a given moment you freeze it, then those particles become uniquely embedded into that fingerprint, and that becomes unique. So, for example, we use about 10 millimeter circle, and in that circle, we use 0.5 millimeter particles. So, the random distributions of this particle is about 10 raised to the power 60. Now, that's a very, very large number because trillion is 10 to the 12. So, you're saying multiply trillion 5 times, and that's the 10 to the 60. So it's almost as good as a human DNA. And the power of this is that with the technology that we presently have, that we can actually image that in a manner that we can use the present mobile devices to decipher that. So you take the barcode and you combine that with this fingerprint, that thing becomes unique, and that can be used on the fungible assets, but it can also connect the non-fungible assets as well. So this basically in a very unique and authentic manner, the way you can be certain that what you're doing is actually cannot be duplicated by anyone. You connect that the physical world again to the digital.
So maybe let's talk about the use cases a little bit, and then we'll circle back to maybe the technology. So obviously, when we talk about we talked about authenticity and real world use cases for proving authenticity. Obviously, what comes to mind would be rare items, collectibles, luxury goods. What are some of the other real world use cases before we start to touch on digital asset more?
There's a lot of really interesting use cases right now, such as there's digital identity with soulbound tokens, or some of the other very specific use cases for identifying things. You mentioned about collectibles. And we think of it when you said about any rare items. Some of the things that we're working on in the ZK and Trustless IRL side right now, um, we have this really interesting use case where people are trying to identify artwork. And so this is physical artwork into a digital space. So if you have this really unique thing from a piece of art, but really want to guarantee ownership with an NFT, not just a JPEG or whatever it is, but you want to make sure that this physical item is linked to this specific NFT, we can actually do that with this technology. There are also things that Dr. Sharma has great experience with in supply chain as well. So if you want to guarantee that things are original, whether they are technically they are identical items, but they should be unique from wherever they come from. So if you're thinking from an anti-counterfeit perspective, these are all things that you could identify and say that, we know exactly what this thing is, where it's produced, and we can identify it during the entire process itself. Dr. Sharma also touched on this as well about, your driver's license or your passport. Those all have barcodes or those type of identifiers as well. We could potentially put this identifier on any of those items as well and really create something that is, again, individually unique. So the use cases, I think of it for me, is that anywhere there is a barcode, which is basically everything that we touch these days, you could actually have this optical fingerprint that Dr. Sharma describes, and you could say that this specific thing we now is merged into the digital world and can be proven cryptographically. It is a patented technology that it is definitely unique, that this is the specific item.
It,
And sorry.
it can also act like a pseudo identity. See, I don't have to tell anybody who I am, except I have this card, the turtle card that we'll talk a little bit more. So basically, I have a number and I have my fingerprint, and that's it. That defines my identity. That can be what you hear about the sovereign secure identity, SSI, or the digital identity. That card becomes my identity. And it is trustless identity in that sense because I don't have to give any other information. I can use that digital identity to access any of the information systems like my emails or anything like that in the Web3 space later on. Or as Chris was saying, think about a collectible. Let's say you have a very expensive painting. You have both of those things. You have an NFT that you have created, both that painting, but you can also uniquely identify that painting, the original painting, with this card, and then you can connect both the NFT and the physical items together through this card, this turtle card that we're talking about. And you can think about, people talk about like the some of these events organizers, they give now the NFT as the ticket, right? Well, so I go to an event, let's say in a football game, right? I can't show them my NFT, but I can give them my card and they can scan it just like the present process. Like if you go to an event right now, what do? They take your card and they basically scan that ticket, right? What we're saying is that because we have the NFT combined with this card, you can scan this card and that is your entry. So no process changes. The same mobile devices that you presently use, because the user acceptance, and in this case the users are the companies, becomes very, very critical. So all I have to do is I show up there, I scan my card, and they know, okay, I have this NFT for this particular event, and they let me in. So as Chris said, any place that you see, whether it is in the healthcare area, whether it is in the supply chain area, whether it is the collectible areas, All those things where you need the the authenticity to be certain that it is who it says it is. That's where the use cases are. The use cases are going to be quite a few uh, things that we have not even thought about. And this one
Right.
card can do all those things.
Yeah, and events are very interesting for that because sometimes if you go to an event, you have to go pass through different gates, right? Like you have to get into the place, then you go up to your, whether it's a box seat or somewhere else, you get another one. Let's say that there are certain things that are attached to that event where maybe you get able to get an autograph or something free or some other type of access. Each one of those times you have to bring something to that or be validated, and an event could really build into this by just simply saying you have a Turtle card and we validate it, and then you're able to access all these different things. So
In
what's intriguing about it is how much you can arguably roll up into the Turtle card, without fear of it being
in
replicated.
Eric, to expand on that just a little, is that because the way the card is designed, if you needed to prove you have the ticket, but also say this is my identity, but do it in a zero knowledge proof in a trustless way, it could be one thing that you scan that proves all of that versus having to scan multiple QR codes, multiple things. So there are certain circumstances where you have to scan your ticket and potentially scan your ID as well, right? So it's actually technically two scans. This actually simplifies all that into one thing. So that's kind of the power of how we've designed it as well. But as I said, it's not just a event access thing. It is really, you could put it on, as we said, collectibles and fine art and everything, and you could really define this unique physical thing with a unique digital thing, and that's where it really becomes very interesting.
But, Eric, as you know, we all live in physical world. I mean, of course, we love digital worlds too, but we live in physical world. And whether we go into metaverse, and I think I heard one of your podcasts, you were talking about the multiverse. That's something that you are using, but is true. So in the Web3 area, there's not going to be a metaverse, it's going to be multiverses. So we go into this multiverse, and in this multiverse, we can do a number of things, right? We can play games, we can buy the virtual properties and all that. But I will also like to place an order while we're there for the products to be delivered to my house in the physical world, right? So we want to be able to basically do all that. So in this multiverse, you still need to be able to connect, whether it is just a plain Web3 or this multiverse based Web3. You still need to be able to connect both the physical assets or the physical items of commerce or any physical thing and the digital thing together. So what Turtle Card does is basically the keystone that connects those two things together. It can connect the digital to digital also, but it can also connect the digital and the physical worlds together by this card. And that's a very, very powerful thing.
So just
Yeah. It's like
yeah,
bridging.
exactly. So just
That's exactly right. It bridges.
thinking about it, like if you go online and you buy something, how do you know that you're getting that actual thing, right? And so, this is, I think Amazon had a huge controversy that there is X% of their goods that were actually counterfeit goods by whatever resellers that were not necessarily selling authentic things. So if you buy it as an NFT that actually does have a Turtle thing attached to it, when you receive it, you can scan that optical fingerprint and know that whatever you bought was really this thing that was delivered as well. And so again, that's kind of the power of understanding, like, if you're going to have this digital physical link, this is how we can really prove that cryptographically.
Right, and certainly when you think about we talked about, being in the multiverse. I don't use metaverse anymore, by the way. So actually, I do, but I try not to. Right? In the because I want to destroy that trademark. Sorry. But in the multiverse, we may want to do things and connect it to the physical world. But what's also intriguing is that, like, back to the event, back to where you enter, let's say, a concert, or you enter into a unique, like maybe it's a championship for, whether it's hockey or baseball or football, and if you buy something when you're there, or you get something that's unique and it has the Turl, that could be scanned into your own Turl card itself, and then connect both the NFT as well as the physical, so that you come out of it with an NFT that authenticates you acquiring that particular item in this particular place at this particular time. And so if you think about things like, Bored Apes or whatever, a lot of that has to do with status flashing, right? You want to be able to say, hey, not only do I own, my favorite quarterback's jersey, but I got this jersey at the game where he threw like 7 touchdown passes, and it's still it's still associated with my identity, it's still in my wallet, and it's like, and I bought the jersey, and I can flash it online, and like, hey, not only was I there, but I got the jersey. Maybe you got an autograph jersey or some sort of autograph memorabilia, and now you uniquely link that collectible to a specific acquisition point.
Exactly.
Right? And
exactly.
Eric, earlier you asked about some of the use cases, but you just defined another very powerful use case yourself. And that was the point we were saying, that it really is just opens the floodgate for the kind of use cases which cannot be done right now.
Right. Because if you think even about the progression from like one dimensionality forward, like if you just think about it, it's like at first we were dealing with sort of classifications of major categories or major like baskets of products. And then as we moved to like a QR code, and there were more products, there was need to be more differentiated. But now as we think about how do we really make something that is fungible, again, going back to this notion, maybe it's fungible, maybe it's a jersey, maybe that jersey doesn't have any, like I could buy it somewhere else, I could buy it on the street. But what might make it more intriguing as a non-fungible item is when I bought it, where I bought it, and the historical significance of that event.
Exactly.
And that's something that, requires a lot of, that 10 to the 60 gives you a lot of room to kind of build out those possibilities, but it does allow sort of this sort of very expansive non-fungibility.
So the other thing, Eric, is that I said 10 to the 60 because that depends upon the particle size. If we go to particle size of 0.2 millimeter, which by the way, the technology that we have, we can still distinguish, that gives you 10 raised to the power 360. I don't even know what it means. Okay.
Yeah, I don't even know how to define that number.
So this could theoretically be marketed to other life forms and civilizations.
Impossible. I mean, the point here is that what we have created is a very, very fundamental technology connecting these different, whether it is Web3 or the multiverses. Now, one of the most important things which I would see in multiverse and Web3 is that we are trying to protect the privacy and the security. You cannot have the protection of privacy and security without the protection on the physical world itself. And that's what we are trying to do with the Turl card and the Turl protocol. And the protocol is the one which gives the power to any of the builders to build these, God knows, thousands of use cases that you can think of. For example, when we tried to take the barcode into the healthcare area, it took us almost 10 years before we could convince the hospitals to start using the barcode. It was so obvious, but now you go any place, right? And you can't really live without the barcode. That's what they do. They scan it as soon as you go over there. It's on your wristband, right? You scan that, and then well, it's supposed to get this medication, that medication, and that medication. So basically, what we have done is we've made sure that the items that are of value also have the unique identity and they're connected. So it's just the use cases are so immense.
And
So, sorry, Chris, were you
no,
going to
I
say
was just
something?
going to say that you go back to the fungibility and then the non-fungibility of things. So this technology really allows any physical item now to be non-fungible in exactly the way that you described. So it's really about authenticity and certification. How do you authenticate and certify a physical item right now? There hasn't been a technology that's been able to do this before, and creating this particular tag allows us to do that. If it has this tag, and there's a lot of different technology that Dr. Sharma has put into this, um, but now we can take mostly any physical item, put on a tag, and now it becomes a very unique, specific thing. And that becomes, and when you think about that, there are really so many different use cases for it.
Great, right. So let's talk a little bit about the technology. Circle back to it now that I think the listeners have an appreciation of the different use cases. You know, it seems like there's definitely there's a very strong like almost counterfeiting component of it, and then there's also an extremely strong authenticity component of it, and also the portability component, which I don't think we maybe have touched on as much, which is like if you go to you go to an event or you have any kind of interaction where you need to produce multiple NFTs. We talked a little bit about the gating, but still the complexity, like you're not going to bring your MetaMask or your institutional wallet and you're going to scroll through it and you know that may be cumbersome with the Turl. It's all sort of built into a recognition of the individual droplet. So it has this sort of, I'd say, ease of use component to it, assuming that you have both the scanner and the producer on each side. It just facilitates it because you can basically, it's unique, it uploads, it sees everything rolled up into it, and then you're able to sort of interact with those NFTs accordingly, like in permissioning.
Yeah, that's exactly the case. Is that the way we've designed it is that a single card can link to any number of wallets, and there's really no upper bound for that. So if you have to have it, whatever it may be, that proves a number of different criteria. So if you were thinking of like you had to prove that you own this NFT as a ticket, but then prove that you are a member of something else as well, but also said like KYC and also have to prove my identity, but do that all in a trustless, zero knowledge way, you would have to do, 3, 4 different scans for every time you want to do that. With this one card, you can do it all with a single scan because we can look and do it in a trustless, zero knowledge way and say, okay, yes, we can identify all of these things, and it makes it really, really simple. And so that's part of the limitation that we've seen for some things that are in the market now is that it's basically a one-to-one relationship. It's basically one scan to one NFT. With this, it is one to many. And that actually makes it a lot more easy to use. And I think that's what, people will appreciate.
Let's talk a little bit about the technology. You know, moving directly to the creation and the manufacture of the droplet. Um, what is the process? How is it imaged? I mean, I'm not looking for the secret patent, but you know, and the authentication and validation. What are the different components that go into both the creation and the scanning technology?
So in terms of the manufacturing piece, obviously we take a viscous material that we dispense onto that area where we want to have the fingerprint. And during that process, we basically drop some of these particles, uh, kind of think about a shaking kind of a thing, and you have these particles. So you drop them, and then you basically cure them in real time on a like a conveyor type of moving machine. So it's basically a process that incorporates randomness in manufacturing process itself, And then also in terms of the scalability, that we can build a lot of these things very, very quickly. So that's the process of manufacturing. Now we built our own machines to do that. Uh, and then during that manufacturing process, we also scan. We have an optical cameras systems, I mean, multiple cameras. So we scan these things, and these things then are stored in a database. And in the Web 2 world, it's very easy because it's centralized, and you basically, if you have it on article of commerce, so you just scan that any place in the world, and basically the answer comes back. You say, oh, this is authentic. This is whatever the information about that product you need, you get that. Now, the challenge in the Web3 world, which is what we're presently working on, and we'll probably have a working platform pretty rapidly in the next few weeks, basically, this information about the entire uh, fingerprint and the associated number with that will be in a distributed, in the distributed nodes, basically on the blockchain. So that's the part now. The beauty of this would be that even though it is not in a centralized server somewhere, it is this in this distributed network, that you will still be able to scan and basically prove that you actually have whatever it is that that thing is linked to. And as an individual who owns this card, I will have the flexibility to connect these assets myself. So there is no centralized server here involved in connecting that. I am the one who is doing that. The information is again encrypted and stored in this distributed network. And when it is scanned, whatever information I want to share, that information will be shared. So not information I just activate. This is the NFT, so that only that part will be visible.
So maybe we could talk a little bit about scaling the technology, both the production and the actual scanners themselves. What are the challenges, obstacles? I mean, it's definitely exciting technology, but the droplets do need to produce it. Maybe once you have the ability to produce them. It's relatively easy and cost effective. But let's talk about the possibilities for scaling.
So the scaling piece is not that difficult. I mean, the manufacturing to begin with will be in a centralized center, at a centralized place. But these cards have no value unless you assign something to it. So you buy that card, of course, you buy that card initially from us, and we can basically have these manufacturing sites at multiple places later on. Anybody can manufacture later on, but initially it will be centralized. You buy these cards as an entity or as a community or individually, and then you use that card, and that card only becomes activated at that moment. Before that, it has no value. The distribution can be multiple places. It doesn't have to be centralized. Initially, the manufacturing may have to be centralized because the process is a little complex.
And one of the
Interesting.
things,
And so I
oh,
guess
sorry, I was just going to say you asked about the scanning scalability as well. The scanning is actually the easiest thing because it can be scanned using mostly any camera, your phone, whatever it is. And we have this in production now where people scan the tag on a single camera, dual camera, now triple cameras, and you can just use your phone to scan it. So there's no special equipment that's required to authenticate the tag itself. So that's,
So anything when you try to do, you need to look at the infrastructure that you would need to support that. In this particular case, there is no new infrastructure involved. The wireless network infrastructure is already there. You don't have to do anything with that. And the scanning device could be your phone, whether it's iPhone, Android phone, and all that. So that one also does not require that. One of the things that I think everybody knows, there is always this constraint about what can you put in your pocket. If anything, you have to put anything extra in your pocket, well, that becomes a non-consumer friendly thing. In this particular case, everybody has a camera, and or any of these mobile device like the barcode scanning devices that you see on these events and all that. So all those things exist, they're already being used. So we're not talking about creating another new device of any kind. The devices exist, the infrastructure exists, and so the acceptance then by the users and the communities and by the organization should be very, very easy.
Right. And I guess it's also, if you think about it, it's an acknowledgement that in a two-dimensional space, authenticity can be very challenging. But once you add that, right? So even like you look at the NFT marketplace, people say, well, that's just a picture. Why can't I just copy that and then, do something with it and claim you don't have the blockchain, but by the same token, you can mimic it. But if you can connect it to a three-dimensional object, you can also validate the authenticity of it,
Yes.
and in a different way. So
Exactly.
Well,
exciting.
That's exactly
it's
it.
not only that, Eric. I mean, think about that. I have a very expensive painting, right? Let's say I can take a photograph of that and I can create an NFT. And that NFT that does become unique, right? However, I can change the lighting conditions and make few other things. I can create another NFT. In this particular case, if you link the original painting or the NFT with a fingerprint like that, that in at that time that becomes unique. And that's what we were talking about, that this is a keystone which can link the digital assets to digital assets. It can also link the digital assets and the physical assets. And of course, it can always identify and authenticate any physical object in the Web 2 and also in the Web 3 space.
Excellent. So a number of years ago, Dr. Sharma and I met prior to sort of expanding this concept into the Web3 space. So the move into the digital assets and the zero knowledge, trustless, roll up, is sort of an evolution. Initially, it was focused on counterfeiting. How has the vision for the adoption path for the technology changed beyond just simply physical to now physical and virtual? How has that evolved, during the time that you've produced it? Like, what are significant pivot moments or changes that you experienced along the way?
So I'm kind of new into the Web3 world. I think Chris and one of the other co-founders of ZK Ladder, Julian, who I think you also know quite well, uh, they have been into the Web3 world and this decentralized autonomous organization space quite some time. And so originally, when I was working with another company where Julian was involved, and we actually were implementing that in terms of the cryptocurrency trading platforms. And again, the idea there was that basically, if you want to trade anything in your cryptocurrency, you can use this kind of a card to basically prove that you actually do own that cryptocurrency. So that was some of the earlier things in the this cryptocurrency area. Now we were using this in terms of the on the Web3 and the supply chain area and all that. But what excited me after Julian talked to me about the and Chris, both of them, and they talked to me about the Web3 world. I see this is like the future, and the e-commerce is going to move into Web3, and these e-commerce sites are going to be community driven. And this community, then each community has to basically make sure that the items on their community-based e-commerce site indeed are authentic. Otherwise, we got the same problem there because now what you're buying is you don't know whether it is real or fake. So what excited me about this is that this is the future, and we need a technology and a solution, and that's why we are working on this protocol that you can actually connect the physical world into this digital world where everything would be online, but in an online, in a web3, in a decentralized autonomous organizations.
Excellent. So, anything else that I haven't asked you that you'd like to develop a little bit on before we wrap things up?
Yeah, I think one thing I can add is that basically the we of course will build some use cases, but the protocol really is for the builders because the possibilities here are really immense in terms of what you can do with the technologies. It kind of becomes a critical element for the success of Web3, in my view, and also to make sure that in the metaverse, when we are in these multiverses, and that from multiverse to physical work, we can seamlessly go back and forth. And even though we think that we're pretty smart guys, there are people who are much more smarter than us. We also realize that. We're giving them a tool and a protocol where they can build their creations in utilizing that. And we actually want some of those builders to work with us and whatever we can do to help them.
So one of the exciting things that we talked about as well is that like we'll do different hackathons for different products and how this can be used. And that's where I think that Dr. Sharma is kind of alluding to is that, you know what, once we get this out in people's hands, they're going to come up with such cool things about how proving physical and digital things is really interesting, proving these digital things is really interesting, and really be able to authenticate and certify that these are really what they indeed say they are. And so we're really excited to see what, you know, we've come up with a lot of cool stuff, but we know that there are going to be a bunch of people that come up with a bunch of cool stuff as well.
Excellent. Excellent. So if people want to learn more about ZK Ladders and Trusted IRL, where can they go?
So TIRL.xyz and zkladder.com. So that's the easiest places to go.
Excellent. And can people who want to learn more about you also, each of you, find more about each of you on those sites?
Yeah, you can find both of us on those sites and LinkedIn and like where, but yeah, people can read up on both of us on ZK Ladder and Trustless IRL.
Trustless in real life, TURL. So TURL.xyz, that's the site. And yes, we do have a Twitter account and all of these other things, and also the LinkedIn account. So yeah, we're approachable there.
All right. Excellent. So thank you so much for coming on the podcast. It was great to have both of you.
Thank you so much
Thanks,
for having
Eric.
us. We really appreciate it.
Yeah,
It's a lot of fun.
very good.